Hey guys, this is Space Train, your daily express till the edge of the space, and today we will talk about the beginning of the universe. Grab your tickets and let's go. Don't forget to subscribe to get unlimited pass on our expedition. The universe is our vast, complex and mysterious home. Science has discovered a lot about it, including how it grew from the initial Big Bang to what we see today. But how it started remains a mystery. 50 years ago, many scientists thought it possible that the universe had always existed. The two main theories were steady state, the continual creation of matter at the center of an expanding universe, so the universe appears the same for all time, and pulsating, the universe goes through regular cycles of expansion and contraction for all time. However, these theories are no longer believed by most scientists. Humans have gazed at the stars and wondered how the universe developed into what it is today. It's been the subject of religious, philosophical, and scientific discussion and debate. People who have tried to uncover the mysteries of the universe's development include such famous scientists as Albert Einstein, Edwin Hubble and Stephen Hawking. One of the most famous and widely accepted models for the universe's development is the Big Bang Theory. Although the Big Bang Theory is famous, it's also widely misunderstood. A common misperception about the theory is that it describes the origin of the universe. That's not quite right. The Big Bang is an attempt to explain how the universe developed from a very tiny, dense state, into what it is today. It doesn't attempt to explain what initiated the creation of the universe, or what came before the Big Bang, or even what lies outside the universe. Another misconception is that the Big Bang was a kind of explosion. That's not accurate either. The Big Bang describes the expansion of the universe. While some versions of the theory refer to an incredibly rapid expansion, possibly faster than the speed of light, it's still not an explosion in the classic sense. Astronomer Edwin Hubble observed, courtesy of redshift, distant galaxies speeding away from each other and formulated Hubble's law, to explain the universe's uniform expansion. Redshift just refers to a distant celestial body's shift toward longer, or redder, wavelengths, complements of the Doppler effect. Meanwhile, physicist Albert Einstein had just completed his general theory of relativity, which provided a model of a finite, homogeneous cosmos shaped by gravity. These efforts laid most of the groundwork for a flurry of new discoveries and fresh theories in the decades ahead. Our modern scientific understanding of the universe provides a kind of roadmap through time. Based in Hubble and Einstein and corroborated by such discoveries as the abundance of light elements and the cosmic microwave background radiation, this map points back 13.7 billion years to an event we know as the Big Bang. At this point in the ancient past, there was no such thing as time or space. There was just a single hot, condensed point, a singularity, containing all matter in the universe. In addition, all four fundamental forces, the gravitational, electromagnetic, strong and weak forces, were unified as a single force. This unified period, called the Planck epoch, lasted 1043 seconds. Then the universe expanded at a rate faster than the speed of light, growing from subatomic to golf ball size almost instantaneously. Scientists call this the inflationary period. The universe then expanded outward in a flood of superheated subatomic particles. In the first fractions of a second, when current laws of physics did not apply, a lot happened. Within a small fraction of a nanosecond, the universe expanded at an enormous rate from a very small size. This is known as inflation, and was necessary to allow the universe to be relatively homogeneous. That means, everywhere you look, it is much the same. Particles began to form out of the enormous energy, first small particles like quarks, gluons and leptons, later the more familiar protons, neutrons and electrons. The four fundamental forces or interactions developed gradually, because scientists believe that these forces are actually caused by an exchange of very small particles, bosons. By the time the universe was 1 second old, It had expanded to a size about 1,000 times the size of our solar system, and the temperature dropped to about 10,000 million degrees. As the age of the universe moved beyond seconds to minutes, and it grew in size to about 1,015 kilometers across, nuclear fusion formed the first of the nuclei we know about today, hydrogen and helium, in proportions that proved necessary for the universe as we know it to form. The universe was still incredibly hot. After several 100,000 years, conditions had stabilized enough for the first atoms to form. After several 100 million years, the first stars, and later the first galaxies, began to form by gravitational attraction. Supernova stars created many of the heavier elements out of the lighter elements, and then exploded them out into space, making them available for planets which later formed, thus allowing the complexity of chemistry on Earth necessary for life. The universe is still expanding today, and scientists are able to extrapolate backwards and describe the early moments of the Big Bang mathematically, predict outcomes of their theory which can be verified by observation of the universe, and show mathematically that the alternative theories have significant flaws. Thus it has been demonstrated that the Big Bang origin is almost certain. The Big Bang theory still provides the best model for how the universe arose, but it's not the only theory we have. For example, the steady-state theory modeled a universe with a consistent density that appears to expand due to the constant generation of new matter. Support for it, however, largely died out, thanks to the discovery of the cosmic microwave background, CMB, in 1965. The CMB was, in essence, the radiation signature of the early, expanding universe. The Eek-periodic model suggests the universe formed due to the collision of two separate universes in the fourth dimension. And the Big Bounce theory suggests our universe is caught in an eternal cycle of Big Bangs and Big Crunches. You can think of such theories and models as piers extending into the cosmic unknown. Tell us in the comments what do you think about the beginning of the universe. There are lots of questions left, so don't space out, and leave some space in your brain. I hope you enjoyed this video. If you want to see more, subscribe and click the bell button to get notifications on our latest videos. If you are still here, grab your knowledge and get out of my train.